Hello everyone, welcome back to my channel. Today we'll talk about combinational logic design using CMOS. So here, very first thing is combinational logic means we need to design digital circuits, and we can implement digital circuits using either sum of product form or product of sum form. It means we need to perform two operations, multiplication operation and addition operation. So when we implement combinational logic using CMOS, we need to take two networks, pull up network and pull down network. Job of this pull up network is to pull this output to VDD, and job of pull down network is to pull this output to ground. So p-channel MOSFETs generates strong value of 1, and that is why we use p-channel MOSFETs in pull-up network, and n-channel MOSFETs generate strong value of 0, and that is why we connect NMOS in pull-down network. Whichever inputs we have, 1, 2, 3, n number of inputs, we need to connect all inputs to pull-up network and pull-down network, and we get output from both pull-up network and pull down network. So as I said, we can implement combinational logic using sum of product or product of sum. So we must remember few rules. You know the characteristics of PMOS and NMOS. So p-channel MOSFET turns on when input is 0, and n-channel MOSFET turns on when input is 1. You need to remember symbol of PMOS. So this is symbol of PMOS with bubble. From this bubble also you can remember that PMOS turns on when input is 0, and symbol for NMOS is like this. So here drain, gate and source terminal. Then you need to remember, whenever we connect p-channel MOSFETs in series, then n-channel MOSFETs are connected in parallel, and vice versa. It means when PMOS are in parallel, then NMOS are connected in series. Then to implement two basic operations, multiplication and addition. For multiplication operation, that is AND operation, NMOS are always connected in series, whereas for implementation of addition operation, NMOS are connected in parallel. Series means one after another MOSFET. So this is my first MOSFET and this is my second MOSFET. They are connected in series, whereas this is series combination. And parallel means their drain terminals and source terminals are shorted. So this is parallel combination of MOSFET. Let's take simple example. Y is equals to AB plus CD whole bar. Whichever rules I have explained, these rules are applicable to inverted logic. So when we implement non-inverted logic like y is equals to AB plus CD only, then we simply need to connect inverter at the output. So let's see how to implement this circuit. So here in this example, you can see the first part is AB, that is AND operation. CD is also AND operation, and this plus is nothing but OR operation. So let's start with pull down network. A, B, AND operation. So to implement AND operation, NMOS must be connected in series. So here A MOSFET and B MOSFET are connected in series. Similarly, C and D are also connected in series. But here between first term and second term there is an addition operation. So these two terms are connected in parallel. So MOSFET C and D are also connected in series, but first term and second term are connected in parallel. To implement OR operation, NMOS are in parallel. So I'll simply short their drain terminals and source terminals. One terminal of this pull down network goes to ground, so I'll connect it to ground, And now let's implement pull-up network. Simple rule is when NMOS are in series, then PMOS are in parallel. So we must draw PMOS A and PMOS B in parallel. PMOS A and PMOS B are in parallel. So their drain terminals are shorted, source terminals are also shorted. Next, C and D are in series. So here also C and D are in parallel. MOSFET C and MOSFET D are in parallel. Here first term is in parallel with second term. So in pull-up, first term is in series with second term. And one terminal of pull-up network will go to VDD. And we need to connect our pull-up and pull-down network. So this is pull-down network and this is pull-up network. So I'll simply connect them and we will get output here. And inputs are already connected to pull-up network and pull-down network. One more thing you need to remember is I have 4 inputs A, B, C, D, and that is why I have taken 4 P channel MOSFETs and 4 N channel MOSFET. If number of inputs are 7, then I need to take 7 N channel MOSFETs and 7 P channel MOSFETs. So this is implementation of AB plus CD whole bar. To implement only AB plus CD, if equation is Y is equals to AB plus CD only, then what I will do? I'll simply connect inverter here. To implement AB plus CD. If equation is only AB plus CD whole bar, then this much portion is sufficient. Thank you so much for watching. In this way, we can implement combinational logic device.